All right. Yep. This is typically what happens during the semester. I'm sure people are making it here, but people stop gradually just showing up, which I understand, but please, it's beneficial to you to come to class. Although that's not directed at any of you because you're here, you know. Um, yes.
The elevator system in this building is horrible.
Yeah, no, I understand, especially if you get to the building at like 10:57 and then you have to wait outside for everybody to queue in. I get it. You know, having been in that queue. So no worries. So how many people have had the opportunity to view the module 4, the linked list modules? Okay. So a lot of people, so a good smattering of people. So let's talk about, so I'm going to talk about module 4 in general, which is linked lists. Now, linked lists are basically our biggest hurdle in terms of conceptual things. This is where most students have to put in a lot of work, or they struggle the most when it comes to trying to understand the concepts I'm teaching in programming, because it requires you to have mastered something hopefully in 1068. I don't know. So how much detail did Professor Fiore go over to, like, about references and memory locations and stuff? Like, well, that objects hold references. Did he talk about that? Okay. Yeah. So it kind of requires you to understand that basically, and let me go ahead and just grab Notepad. Okay. It does not matter. Basically, if I have something over here, the assignment statement always works like this. The variable on the left and the expression is on the right. Okay. Okay. And the expression yields one of two things. It yields either a primitive value, okay, in which case that's just the value actually stored. But in this class, the more often the case is, that expression yields a memory location. Got it? So the way this works is that when we've got an assignment operation, the way to keep your sanity for this chapter is, remember the following: the memory location on the right gets stored in the variable on the left. It's always a variable on the left. Everything is just variables on the left, and everything is memory locations on the right. Okay? The memory location is where something is located, you know, that holds where we find this object in memory. Because what linked lists are, you know, for array lists, we just have this big contiguous array that we stored in memory. Linked lists aren't like that. They have each item is held in a box, and that box has two pieces of information, generally. One or two pieces of information. Where you find the next item, where you find the next box, and where you find the previous box. It also has the memory location of the actual item itself, but it's often more conceptually easier to think of that box holding the item, right? But it's all memory locations. It's all memory locations all the way down. This is because, now, it's also worth noting that Java is a pass by copy language. That means when you're passing something into a function, you copy it. But when you pass a list into the function, you're not copying the entire list, because what is inside that variable? It's a memory location. So you're copying where to find a list. This makes sense if you think about it for about 20 seconds, because if I'm copying if I was to copy the actual list, I'd be copying like a million items if I had a really big list. And that would be extremely, you know, onerous on the hard disks or on the processing. Okay, so everything works with memory locations. This is for those of you who have taken C, Java is just simply doing all that nonsense with addresses and with the address of a variable or dereferencing a variable. It's handling all that for you behind the scenes. It's doing it for you automatically if you're coming from C. And that's a breath of fresh air. Trust me. Okay. So with linked lists, this is where I really went into detail in the videos, you know, and the majority and almost all of this video, this entire series is how you build a linked list from scratch, because linked lists are just lists, so they do the same thing as lists. You know how to use lists already. Great. So here's how you build a linked list. The key now, why are we doing 2 lists? Because linked lists are great at the things that array lists are terrible at. They're great if you want to add to the beginning or the end. And they're terrible if you need to grab something out of a random index. But they can also do things that array lists can't, like be split in half very easily, combined with other linked lists really easily. It's these operations can be, depending on on the level of support you give them, constant time. They're very good at that. So you know, go over these videos. Now for this homework, as I think I've mentioned, I have given you so you've got those self-check quizzes. Make sure you take them to check that you understand. Again, those quizzes, as long as they're done by the end of semester, you know, I don't really care when you do them. So there's 2 assignments here. One, you get to choose one. You'll get the 0 on the other. Don't worry about that. The 0 is automatically dropped. If we look at my assignment, so let me go ahead and just discuss that for a second. Okay. If we look at my if we look at my, okay, yes, those are papers. I was worried for a second that you could see the exams. All right, so if we look at these rules over here that I have set up for this, which I don't think you can see, it's got, for this assignment group, I've got 2 rules for the assignments, which is I drop the 2 lowest ones, and I never drop Cheater's Hangman. Those are the two rules I have for this, okay? So one of those 2 drops will be the assignment you didn't do. It's just simply a hack. So technically I'm just dropping 1 lab. Just keep that in mind for the end of the semester. If you're feeling overwhelmed, there is a drop. So you do get a drop on there. Yes.
You know what? I'll let you.
It's automatically is handled.
I was gonna ask something else about the format of exam.
I will get to that when we get closer to the exams. Okay. Which will probably be not the exam won't be next week, but it will be, I'll start discussing the exam next week. Okay. But regardless, so you've got 2 problems. You've got the Josephus problem if you're feeling less comfortable with the material. If you're feeling like your other classes are really bogging you down or making you prep for exams already, then the Josephus problem might be the way to go. And then the solitaire encryption is for the students who are feeling more comfortable or they want a challenge. Now, here's the thing about the solitaire encryption. Why would you choose the more difficult one? Because because these are worth 200, because Josephus is worth 200 out of 200 points. Solitaire encryption is 220 out of 200 points. Okay, so that's a lot of extra credit points right there. A lot. So if you do the solitaire encryption, you can. The other thing is that you can try the solitaire encryption and immediately back out of that because they both use the same base file. You have to complete the base file before you can move on to the next step. Notice that the Josephus problem, I just give you 1 Java class to complete, where solitaire encryption requires you to complete 2. So if you do this and you get to the solitaire encryption and you're like, I don't have time for this. You've basically done 90% of the work you needed to do to solve this problem. Okay, so just keep that in mind. Similarly, if you find that you're breezing through this, you might hop over to solitaire encryption. So, what are the 2 problems I give you? So the Josephus problem is an ancient problem, or a problem with an ancient base, based off of Josephus, or Josephus, if I can spell, Flavius Josephus, a 1st century Romano-Jewish historian. He is of particularly note because of the time he was born and his writings. So he initially fought against the Romans during the, as it says here, during the Jewish-Roman War. So the Roman Empire, as you may know, it did a lot of conquering and imperial stuff, and they love taking territory. And when that happens, you typically get uprisings because for various reasons. From one group to another, the reasons vary, but it's an uprising. And this uprising ended the way that most uprisings against the Romans did, poorly. So anyway, so Flavius Josephus at that time was captured during a siege. And I'll go into that a bit more. He was taken as a Roman slave. Then he basically he claimed that basically that the general who he surrendered to would become the emperor of Rome. And so he said, okay, I like you. Flattery will get you anywhere. So he took him as a slave and eventually freed him, in which case he stayed in the emperor's family. So, so why is he important? Because he wrote a whole lot during that time period. Jewish Wars, the Antiquity of the Jews. Now, if you're thinking about this, the histories that he's writing about here about Jews include some history about early Christianity as well. We're talking really early Christianity, since AD would be basically, when Jesus Christ was born. So that's year zero there. And he's writing about stuff around this time. So he's got a lot of basically stuff that he can write about, not just early Christianity, but Jewish receptions of early Christianity, significant and independent extra biblical accounts of his figures such as Pontius Pilate, Herod the Great, John the Baptist, James the Just, and possibly Jesus of Nazareth. So he had a lot of, he had a lot of stuff to write about. Now, the problem he's named for is less well known if in the historical circles, but way more known about in mathematical circles. So the idea here is that when he was and this, forgive me, but this is a bit of a morbid problem, but it is. So I do mean morbid. So just be aware of that, okay? So what happened during the siege was that a bunch of Jews, they decided, okay, well, I'd rather die than go into slavery. So they didn't want to commit suicide. So what they did is that they drew lots, and then whoever drew the shortest lot, or whoever was decided by the lot, would be killed by the others. So basically what happened is that Josephus and one other dude, they were doing this in this entire bloodbath, and then they looked at each other, I guess, and said, well, this was a terrible idea, and then immediately surrendered to the Romans. So anyway, the way that lots were typically done in this, or the idea that, the presumed way that the lots were done in this problem, were that you would stand in a circle and every other person would be removed from the circle permanently. Here is showing that problem, what would happen if every third person was removed from the circle. 1, 2, remove the third person. 4, 5, remove the sixth person. 7, 8, and so on and so forth. Go on and remove the people until it circles around back. 39, skip, remove 1 from the circle. And it just spirals in. So the Josephus problem says, where in the world do you want to be in the circle to make sure you stay in the circle? That is the Josephus problem in a nutshell. Now there's a lot of, as you can see, fun math and all sorts of equations that look nice and spooky. Oh, especially the generalized form. Doesn't that look lovely, right? The generalized form for the equation. Given a circle of size n and you're removing the kth person, where is the safe, what is the safe place to stand? That's the generalized equation. Looks kind of not great, right? It's all recursive and nonsense and stuff, right? That's hard. But rather than doing that, what we're going to do for that problem is that we are going to program this problem and simulate it using a linked list where every node represents a position. Okay, so that's how we'll simulate this. I go into detail about how to solve solve this in the Josephus.pdf, right? I took this from a textbook that we used to use here, but it's pretty awesome. The big thing that's going to make this problem distinct from doing the solitaire encryption is the use of the iterator. I've created an iterator for you, and you'll want to use it in your program. And I will help you get that set up if you have trouble, but you don't need to change the iterator. You're just going to use it because it's going to keep track of all that nasty stuff about indexes, so you don't have to. Make sense? So you don't have to worry about what index you're on. You just have to use .next calls and .removes through the iterator. The iterator will remove method hooks into your remove method that you will be writing. So, and finally, last to note, the toString will crash. Your toString function, the toString function I provide you will crash if your linked list is not set up correctly. This is a feature, not a bug. This lets you know whether or not it's working. Okay. So on the other side, we've got solitaire encryption, which is a real fake algorithm made for fake characters in a real book. So there's an author called Neal Stephenson, and he likes to show his work when he was doing stuff. He wrote a book called Ream. So one of my favorites is ReamD. That's possibly his most approachable and open and easy to read book involving MMORPGs, essentially virtual currency, the Russian mafia, Chinese gold farming. If in MMORPGs, it's not farming for actual gold, farming for virtual gold in MMORPGs. It's a real thing. It touches on a lot of stuff. It's a very good book. The other book that he's known for was Cryptonomicon, which documents which is a fictional account of the cryptography warfare that went on during World War II, as well as stuff, fictionalized stuff going on in the current in what was then the current day. So two of the main characters in that novel covertly communicate with each other using a deck of playing cards and using the solitaire encryption algorithm, which was created in real life. So my documents go into a whole lot of detail about how this is generated. Not only that, I link a video about how this works. But for this one, I highly recommend you get a deck of cards and work with it. The thing to note is that for simplicity's sake, we're only going to be using half a deck of cards. There's 26 letters in the alphabet. There's 52 cards plus 2 jokers that, and 52 divided by 2 is 26. That is too nice of a coincidence not to use. So we're just going to use we're just going to use those 26. So we use essentially half a deck. It goes through a couple of different examples of how to use it. And finally, going back over here, I've got a video that on YouTube showing somebody actually physically performing this algorithm. It's pretty nice. The general, and I'll remind you of this, but the general test I do for this one is I try to encrypt hello, and I expect, and if you use the starting deck configuration that's provided in the PDF, which is 1, 4, 7, 10, basically counting up by 3s, then that should encrypt to SNISY, S-N-I-S-Y, which I don't know why it is, but it's easy. It's there, but it's easy to pronounce. It's a very fun assignment. I did it as I used to do. Before the pandemic, I had that instead of the Josephus problem. And then I found that, it was a bit of a hard pull for some students. So I found that both the Josephus, that letting you choose was the better approach. Okay. But conceptually, this is the most difficult. Will be possibly the hardest you'll have to lift all semester. By which I mean that, it's not that other assignments won't be as hard, but it's the fact that basically this is the first time you're going to have to do something difficult. There's not going to be anything harder than this. Some of the assignments might be as difficult at some point, but they're not going to be as tough as this if you're if you're having trouble with the kind of concepts that are happening. I currently have the due date set for the 17th, which is about 11 days from now. If you need more time, that's just preliminary. If people need more time, please let me know and I can adjust the due date accordingly. Your exam for this class, so getting to what you were talking about, will occur in lab on week 6, meaning that it will be on the 21st. Okay. So, and it will cover and it will cover all the way through linked lists. So it's on week 6, it covers through week 4. There were not going to be stacks and queues on this, on that exam, because stacks and queues essentially are just really simplified linked lists. So if you know linked lists, then you can do stacks and queues, obviously. Okay. They have their own use cases for helping you frame how to think, but otherwise, yeah, the 21st will be the exam. I will definitely review on the 20th. I'll provide a practice exam at no later than the next Monday. Okay. I will decide on the format of the exam, but generally for the past, it's been basically a couple of different questions. It's been the format. So to get into that, just to answer your question, because you asked, the format of the exam has generally been, I think, around 2 drawing questions. So 2 questions that require you to draw a linked list. Okay, so given a code, here's the starting linked list. Draw what happens to this list step by step. Yes, it's electronic. So, okay, you'll either draw it on the computer or you'll draw it on paper, take a picture, or you'll draw the picture and hand it to the TA. You know, I'm very flexible about this, okay? Second, the next 2 questions, I generally ask 1 or 2 questions about writing a linked, here. I ask 1 or 2 questions that are similar to those questions that would have been on lab 2. So given a list, do something to a list, right? Such as, maybe remove all the positive numbers from a list or something like that. Okay. Those are typically followed up by 2 minor questions. For big O stuff, how do I test that? Very simple. For questions, for those kind of questions, I typically ask, what is the big O of what you just wrote? And my answer, and what I'll tell you is that you probably won't write it in constant time. So you either wrote something that was linear or quadratic, one of the 2. It's not going to be, unless you did something really crazy, it's not going to be anything else. It's not going to be anything else. It's going to be linear or quadratic. Then the other one, then I ask you 2 questions about actually writing functions inside a linked list that would do something. They are typically symmetrical to or complement the problems in the practice exam. So, but those are the bulk of the work. And typically the way I've done that in the past, I've said your algorithm must run in, like in my rubric, I'll have like 5 points. Your algorithm runs in O of n in linear time, which means if you can't solve it by doing it in linear time, what should you do? See if you can solve it by writing a quadratic equation and just take the 5-point hit. Those problems are generally are worth a lot of points. Generally, they're not worth 10. They're typically somewhere between 15 and 25 for those. So if you can't solve one of those by doing a linear time algorithm, just use a quadratic algorithm. No problem. And you'd rather get a solution on the board, even if it's not the optimal solution. And I've already told you what one of the questions are going to be, which is compare and contrast array lists and linked lists. Now, with regards to that, again, what resources will you have? Everything in front of you. You can use your computer. You can use IntelliJ. Your only limit is that, and I send these instructions out before the exam, and you'll have them in front of you during the exam. The only restriction is that you cannot use the internet except to reach Canvas or anything connected to Canvas. So that means, and you can use anything that you've got like into your Google Drive or OneDrive or iCloud, anything, any cloud kind of storage note thing that's permitted. But like, so my GitHub, that's totally available. My YouTube videos during the exam, you can totally reference those. Just be sure to, you know, have them muted or use headphones for those. So those are total. I try to be as reasonable about these things, but I have to put a hard limit on basically being able to Google the answers. Because otherwise that makes it really difficult for me to write questions. All right. So hopefully that answers your questions there. All right. So that's all my announcements for the day. Hopefully that, again, choose which one you think works better for you. I will be more than happy to give you advice on either. Again, they both use the same base code, which requires you to write the add and remove functions for a circular linked list. It doesn't have to be doubly linked. Okay. So stop recording.